The interstellar object 3I/Atlas has captured the attention of astronomers and scientists worldwide due to its intriguing characteristics and unique features, setting it apart from typical comets observed within our solar system. As of today, December 14, 2025, 3I/Atlas is approximately 275 million kilometers from Earth, with light from the object taking 15 minutes to reach our planet. The image delays of 15 minutes reflect the immense distance between Earth and this object, making it a fascinating subject of study for astronomers and researchers. These delays are a fundamental aspect of observing distant celestial bodies, as it takes light that long to travel from 3I/Atlas to our planet. This time delay gives a unique perspective on how we perceive objects that are not part of our solar system, highlighting the vastness of space and the time it takes for light to travel through it. As we continue to observe the object, it will approach Earth more closely in the coming days, with its closest point, or perigee, expected on December 19, 2025, at a distance of about 9,097 million kilometers. This distance, though smaller than its current position, still illustrates the remarkable scale at which celestial bodies interact and move within our galaxy. The approach of 3I/Atlas provides an opportunity for astronomers to capture more detailed observations, as its proximity allows for enhanced imaging and study of its physical properties, such as the mysterious anti-tail that has fascinated researchers. The most recent image of 3I/Atlas, taken on December 13, 2025, at 21:30 and 26 seconds Universal Time coordinated by Tirasak Thaluang using a 0.26-meter telescope in Rayong, Thailand, has further fueled scientific curiosity. The image reveals a prominent anti-tail, which is unusual for comets, as they typically exhibit tails that point away from the sun, driven by solar radiation and the solar wind. Instead, the anti-tail of 3I/Atlas points directly toward the sun. This is not a temporary effect caused by perspective changes as Earth crosses the comet's orbital plane, a phenomenon that had been observed in previous comets. Instead, the anti-tail of 3I/Atlas is a permanent feature that has been observed consistently in images taken over several months, making it a subject of great interest to scientists attempting to understand its origin and composition. One of the first recorded observations of this anti-tail was captured by the Hubble Space Telescope on July 21, 2025, when 3I/Atlas was still approaching the Sun at a distance of 2.98 times the Earth-Sun separation, or 2.98 Australian dollars astronomical units. This marked a pivotal moment in understanding the nature of the object, as the anti-tail appeared prominently in the Hubble images, showing a clear glow extending from the comet toward the Sun. Another key Hubble image, taken on November 30, 2025, further confirmed the presence of the anti-tail, even though 3I/Atlas was now receding away from the Sun at a distance of 1.91 Australian dollars from Earth. In both instances, the anti-tail was visible, raising questions about its nature and why it persisted despite the changes in the object's position relative to the Sun. What sets the anti-tail of 3I/Atlas apart from typical cometary tails is that it is not a result of the solar wind pushing gas and dust particles away from the Sun. The solar wind and radiation pressure typically push particles away from the Sun, creating the traditional tails we observe in comets within our solar system. However, the anti-tail of 3I/Atlas defies this expectation, as it points toward the Sun rather than away from it. This is a phenomenon that has never been observed before in such a clear and consistent form, which has led to the development of several theories attempting to explain its origins. Several possible explanations for the anti-tail of 3I/Atlas have been proposed by scientists. In two peer-reviewed papers co-authored with Eric Ito, the first theory suggests that the anti-tail is caused by the scattering of sunlight by fragments of ice that have been shed from the sun-facing side of 3I/Atlas. As 3I/Atlas moves through space, tiny ice particles are released from surface, and they evaporate before they can be pushed back significantly by solar radiation pressure. These ice fragments are small enough that they do not form a typical cometary tail, but instead create a subtle glow that extends toward the sun. This theory provides a potential explanation for the unusual appearance of the antitail, as it suggests that the physical properties of the object and its interactions with sunlight lead to the formation of this unique feature. In addition to the ice fragment theory, a second hypothesis proposed by the same papers attributes the antitail to a swarm of objects trailing behind 3I/Atlas due to its non-gravitational acceleration away from the sun. This acceleration, which is not caused by gravitational forces, but by forces such as outgassing or radiation pressure, causes the object to move in a way that results in a trailing swarm of smaller bodies. These objects would not be gravitationally bound to 3I/Atlas, and as such, they would appear to lag behind the object itself, potentially creating a visible antitail. This theory provides an alternative explanation that focuses on the non-gravitational acceleration of 3I/Atlas as the driving force behind the phenomenon. A third paper, which was authored solely by Tirasak Thaluang and published on December 8, 2025, explores the possibility that the antitail is directly related to the peculiar motion of 3I/Atlas itself. According to the paper, the object's non-gravitational acceleration away from the sun could explain the formation of the antitail, as the objects trailing the comet would be pushed in such a manner that they appear to form a jet-like structure extending toward the sun. This hypothesis places greater emphasis on the unique physical properties of 3I/Atlas and its interaction with the sun's radiation and solar wind, suggesting that the object's own behavior is responsible for the creation of the antitail. The explanation of the antitail remains a subject of active research, and the latest observations, including the Hubble Space Telescope images, may provide further insights into its nature. As the object approaches its closest point to Earth on December 19, 2025, astronomers hope to capture even more detailed images and data, which may help to confirm one of these hypotheses or suggest a new explanation entirely. The mystery surrounding the antitail of 3I/Atlas underscores the complexity of interstellar objects and their behavior as they pass through our solar system. It highlights the need for continued observation and analysis to fully understand these objects, which may provide crucial insights into the nature of interstellar space and the processes that shape the bodies that travel through it. In conclusion, the antitail of 3I/Atlas remains one of the most fascinating and mysterious phenomena observed in recent years. Its presence has challenged conventional understanding of cometary behavior, leading scientists to propose multiple theories to explain its origin. Whether caused by ice fragments, trailing objects, or the unique behavior of 3I/Atlas itself, the antitail provides a glimpse into the complexities of interstellar objects and the forces at play as they interact with the sun and the solar system. With further observations expected in the coming days, it is likely that more answers will emerge, deepening our understanding of the wonders of the universe and the phenomena that exist beyond our solar system. The study of 3I/Atlas is a reminder of the mysteries that still await discovery in the vast expanse of space, and it highlights the importance of continued scientific inquiry in the pursuit of knowledge.